My name is Maria Gonzalez-Pons. I'm an assistant professor at the University of Puerto Rico Comprehensive Cancer Center. I'm also one of the pilot program awardees from the RCMI program. Today I will present my project titled Characterization of Stool Metabolites in Puerto Rican Hispanics. Colorectal cancer is one of the most diagnosed malignancies worldwide. Incidence is projected to increase by 52% by 2030. In Puerto Rico, colorectal cancer is the leading cause of cancer death, while in the U.S. it is the second leading cause of cancer death. Hispanics in Puerto Rico have been reported to have worse survival than other racial ethnic groups in the mainland U.S. The etiology of CRC is complex. However, inflammation in the gut microbiota are considered major contributors to colorectal carcinogenesis. Currently, routine screening is the only way to prevent CRC. The development of new preventive strategies based on modifying risk factors is critical in order to make strides in reducing the burden of colorectal cancer. Our working hypothesis is that individuals with an unhealthy diet may develop dysbiosis. Dysbiosis is a shift from a healthy balance between beneficial bacteria and detrimental bacteria. This leads to increased inflammation and bacterial metabolites that may perpetuate inflammation, leading to the development of adenomas and eventually colorectal cancer. The specific aims of our study are: 1. To determine which bacterial taxa are associated with colorectal adenomas, and 2. To identify which metabolites in stool are associated with colorectal adenomas. We will show preliminary data from aim 2. Using a case-controlled study design, we recruited 50 healthy individuals or controls and 50 individuals with colorectal adenomas. We collected stool samples and also sociodemographic information. Once we had the stool, we extracted metabolites from stool and subjected all samples to gas chromatography mass spectrometric analysis. Our preliminary results show that when combining all samples, 24 controls and 17 adenomas, the main metabolite classes detected by untargeted metabolomics were amino acids and fatty acids, followed by sterols and purines. Preliminary principal component analysis showed that metabolite profiles were sufficient to discriminate between adenomas and controls irrespective of sex. Although adenomas tended to have higher concentrations of cholesterol and amino acids and lower concentrations of adipate, no significant differences were found when comparing adenomas to controls. Today we show preliminary metabolomic data from 41 of 100 samples. The analysis of the remaining samples is currently underway, and we expect to detect adenoma-specific metabolite profiles. We will also be working toward finalizing our gut bacterial community profiling in order to determine which bacterial taxa are associated with adenomas and/or particular metabolites. It is critical to understand which environmental factors, such as gut bacterial communities or metabolites, increase susceptibility to colorectal cancer in order to move towards identifying individuals at higher risk or developing prevention strategies. I would like to acknowledge everybody that has collaborated in this project, specifically Llanos from the Promics facility at the UPR Cancer Center and Dr. Natalia Chorna from the UPR.